All righty, it is October 31st, the last day of the 10th month of the 2024 year of AD. And so we're going to jump right into all things geometry today. I think it's going to be a little bit easier than it was the last couple lessons, which we'll say that's good. Even the proofs that we've had, and I don't know, we'll get to all the proofs, but the proofs are quite a bit easier. I know some of those proofs, and when we do them, we have to create all this content. Did I record? Yeah, I'm recording. I'm getting forgetful. But we know that when we're actually doing the teaching textbooks, not only do they fill half of that in for us, they also are giving us multiple choices on the parts that we fill in. So it might look rather daunting and difficult from the standpoint of where reason, statement, reason. But when they're giving you half of that information to begin with, and the information that you have to provide, they're giving you multiple choices, then it's not as difficult as it appears. Is that true or is that not true? Still difficult, Mr. Soto. Well, neither here nor there. Let's jump into a couple things. We're going to do a few things. I'm going to show you something, and it's going to make some sense, and it's some things we've kind of already seen, but we maybe can now process. Let's think of a triangle here, and I'm going to do this triangle like this. Okay, and we're going to call this triangle A, B, C. And you say, Mr. Soto, why did you extend the lines out? Because I want to show you something. And sometimes you'll have a triangle like this, and you'll have just one line extended out. But theoretically, unless it says line segment, you can extend lines, right? And such. So that being said, we're going to see this triangle here. And we're going to conclude some things. Okay, let's just say, I'm going to just throw out random arbitrary numbers here. And let's just say that we have a measurement of 40 degrees here. We'll call this 90 because it kind of looks like a right angle. And we'll call this 50. Okay. Now watch. This plus this plus this is going to equal 180. We know that already, don't we? Because all of the angles inside a triangle, the sum of all the angles in a triangle is equal to 180 degrees. So even if they didn't give us this, we would know that this is 50. We know that this is something we've already learned. Is that correct? Thumbs up on your emoji if that's correct. We know that already, don't we? Yes, yes, yes. Yes, yes, yes. Only one person said yes. 2 people said yes. Is there a third thumbs up? 4th thumbs up? All right, 5th thumbs up. Okay, so, all right, perfect. So we could fill this in. But let's go ahead and think about this also. We also know that this measurement right here plus this measurement right here also equal 180. I shouldn't put that 180 there. I should put, let me erase that because I don't want to throw you off. So we have this plus this plus this equal 180. So angle, let's say measurement of angle plus measurement of angle plus measurement of angle equals 180. We also know that the measurement of this angle plus the measurement of this angle also equal 180. Because any straight line, it has, if it's cut by a line or a transversal, the sum of the 2 lines is 180. So can't we then conclude that this plus this is going to equal to that, right? Because we know that this plus this is 180, and this plus this is 180, so this plus this must be equal to that. So This is one of those theorems again. These are called, by the way, let me erase everything here and just give you some thoughts as well. So we're going to say these are called the interior angles of a triangle. These are actually called the exterior angles of the triangle as well. So a triangle has exterior angles as well as interior angles. So the measure of an exterior angle of a triangle is equal to the sum of the two alternate interior angles. So anytime you have, again, so you could have something that looks like this. The measurement of the exterior angle of this triangle is going to be equal to the sum of the two alternate interior angles. Not this one, but these two. That's where the word alternate. So the measurement of an exterior angle of a triangle is equal to the sum of the alternate interior angles, the other two interior angles. All right. The other two interior angles added up are going to be the same as the exterior angle of the third angle of its supplement of the third angle. That's another way to word it. Okay. All that being said, I want you to give me a thumbs up or a thumbs down if you completely understand what I just said. On the count of three. One, or thumbs down if you didn't. Doesn't that just make sense? We've kind of already dealt with that before. We just have never expressed it just yet. Okay, so let's go to our sheets of paper that we have here. Let's start with 13, 14, 15, and 16. And then we'll go to some of the other stuff because that is review. All right. So actually 13 is review from the last lesson. We already know how to do that. Let's go ahead and look at 13 and let's see if we can draw some conclusions to 13. They said this angle is 42 degrees. This angle is 26 degrees. They want to know the sum of this angle. So all we have to do to find this angle, because these are all three interior angles of this triangle, right? So the sum of all the angles of a triangle is equal to 180 degrees. So if we know 42 and 26, we just have to add those together. Then we just subtract that total from 180. $112 degrees. So the answer to number 13, as we can see, is 112 degrees. Yes? Okay. Perfect. You should know how to do that. I wouldn't even call this high school level geometry. I would call that middle school level geometry for number 13. Each angle adds up. Oh, I'm sorry. The sum of all the angles add up to 180 degrees. If you have two of the three angles, all you have to do is add the two you have, take the total, subtract it from 180, you get the third. Easy, cheesy, lemon squeezy. Those are the interior angles. But now we have some exterior angles, and let's see if we can, again, we could do this two different ways. We could say to ourselves, if this is 50 and this is 70, then 50 and 70 is 120, and 120 minus 180 is going to be 60. So this angle has to be 60, right? We already learned about the 50, 60, 70 triangles because 60 times 3 is 180, and 50 is 10 less than 60, and 70 is 10 more than 60. So 50, 60, 70 is a common scalene triangle, right? So we already know that a little bit. But even though they didn't tell us the angle here, we could look at this and say it's got to be 60 because 50 and 70 is going to equal 60. We also know that this straight line cut by this line the sum of two angles that create a straight line is going to be 180. So we know that we could figure this out to be 60, but now we kind of know a little trick here. This angle here is going to simply be the sum of the opposite angles, of the opposite interior angles of the triangle. So all we have to do is say, if this is 50 and this is 70, and without even worrying about this here being 60, we know that 50 and 70 is 120. So this angle right here is going to be 120. Okay. All right. Well, let's go ahead and take this one step higher as well. Would you all agree that so far this has been easier than the last 3 lessons? Thumbs up if you agree. Okay. Only one person agrees. All right. 2 people agree. 3 people agree. 4 people agree. All right. Here we go. Number 15. So conversely, let's do this. Couldn't we say then, if this plus this equals that, if 3 plus 5 equals 8, then 8 minus 5 equals 3. So if this plus this equal this, then this minus this must equal that. Is that true? Yes? So we say if this is the x that they're asking us for, then all we really have to do is say this minus this is going to equal this. You see my little illustration? If 3 plus 5 equals 8, if this plus this equals that, then this minus that should equal that. And that minus this should equal that. 8 minus 5 equals 3. I just put these numbers in here. Very simple. The commutative property of addition says that order doesn't matter. And then it goes on to say later that the sum of 2 addends would be, when subtracted by either addend, would be the other addend. And that might be another property besides the commutative. But anyways, we know that to be a mathematical principle. So all I have to do then here is this. 105 minus 68 x equals 37 degrees. So even though you say, well, I need 3 of those 4 angles, theoretically, you don't even need that. With the 2, you can solve for this one. And then if you wanted to, you could, I mean, this one here, we know if this is 105, this is going to be, 75, right? Yeah, 75. Have to be, because 105 plus 75 is 180. But we don't need to know that. I mean, you could figure that out. You could say this is 75, then 75 plus, 68. You could do all that. 75 plus 68. And then, but that's so much work. You don't even need to do that. All right. All you need to do is this minus that would equal that. So that makes sense. That being said, do number 16 and give me your answer. Just in the event that somebody doesn't have their paper with them, I'll draw it for you. That's how nice of a math teacher you have. That's 25 degrees. They want you to solve for x. All right. Remember, this angle here will be the sum of these 2 angles. Very easily, you can find this angle by 140 plus this equals 180. This plus this equals that. Hello. Going once. Going twice. All right. If this is 140, oh, here comes Q. I'll let her get on real quick. We're doing one right now. It's Ariana, we're doing number 16, and I'm waiting for a student to give me an answer, but not one is even participating. They don't want to do the work. Mr. Soto, we don't get it yet, okay? I'll help you. That's what I'm here for. Okay. So because that says x squared, I should say x degreed there. Sorry about that. That threw you off. I apologize. That should be x, and I need to have a degree sign there. Okay. Don't need that. I need this. X to a degree. Okay. So what's the measurement of x? This is 25. We know this has to be 40 because 140 and 40 is 180. And we know the exterior angle is going to be equivalent to the sum of the two opposite interior angles. Opposite. So 40 plus 25 is 65. So the measurement let Olivia on right now. All right, just so I know, Olivia and Ariana, you just jumped on right now. So the principle that we learned here already in the first 20 minutes is this angle, these are called exterior angles of a triangle. All three of the interior angles equal 180. And since all three of the interior angles equal 180 and a straight line cut by a line, the sum of those two angles equals also 180. The measurement of this angle here, the exterior angle outside of the triangle, is going to be equal to the sum of the two alternate interior angles of the triangle, meaning not the one that connects. So this x is going to be equal to 65 degrees. And I gave a much more thorough explanation of that earlier, as well as doing 13, 14, 15, and now 16 for you right now. And that's the main gist of lesson 31, is the measurement of exterior angles is equal to the sum of the two opposite interior angles. And you can say alternate or opposite interior angles here. So this measurement is going to be equal to these two, which makes sense. If all three of these equal 180 and this equal 180, then this must be equal to the sum of this and that together, and it will every time. So these are the principles you just need to kind of learn on the geometry. Okay, let's do this. Let's do 17, 18, 19, and 20 on lesson 31. Then we'll back up and do 11 and 12, and then we'll flip the paper over and do lesson 32. Okay, so these are going to go actually a little bit quickly. So let's, anybody want to jump on with your audio and read? Well, I'll just read them for you. Let's look at number 17. Before it, the instructions say, tell whether it is possible to draw a triangle that satisfies each set of conditions below. Okay, so here's the conditions. The first one. Can you draw a right triangle with two congruent triangles? Let's ask you that. Is it possible? Thumbs up. Is it impossible? Thumbs down. I want you to all be ready so nobody gets skewed by anybody else's. I'm going to say 1, 2, and then I'll say the next number. When I say that number, you're either going to go thumbs up. If it's possible, thumbs down. If it's impossible, a right triangle with two congruent angles. Here we go on the count of 3. 1, 2, 3, go. All right. 3 of you participated, and you all 3 are correct. It is possible because you can have a 90, 45, 45. And that's actually got some really special characteristics on solving. It's really going to be cool if we ever get to that. One of the geometry curriculums I did, they gave you the 30, 60, 90 triangles and its special characteristics, and the 45, 45, 45, 45, 90 right triangles. We haven't got that far yet, but so here we go. The answer, yes, it's possible. Number 18. Don't answer yet. I'll give you the 1, 2, then the next number in a second. Can you draw an obtuse triangle that's also equal angular? Equal angular will mean all three angles are exactly the same. Obtuse means the angle is over 90 inside of the triangle. Okay? So on the count of 3, is it possible? Thumbs up meaning yes, that is possible. Thumbs down meaning no, that is not possible. See if we can get a little bit more participation. We have 9 of us in class, including me. 3 participated the last time. Starting to give me a complex. On the count of 3, yes if it is, no if it's not. 1, 2, 3, go. All right. One person's answered.
I want to put thumbs down, but for some reason it won't let me, so I'm not.
Okay, no worries. Maybe you don't have the access to that. All right. You could write thumbs down. All right. And the reason being is, obviously, in a triangle, the sum of all the angles must equal 180. And so, there you go. You got it. Oops. And equal angular, they have to all be 60, don't they? Because if all of them, if it's equal angular, 180 divided by 3 is 60. Equilateral, equal angular. And if it's obtuse, one of those has to be more than 90. So both of those have to be, the sum of both of those has to be less than 90. So you can't have equal angular. And yeah, I see people are typing to me too. So if other people were doing that, I wasn't seeing those chats, but now I do. So there you go. Yeah, so participation I see on the typing too. So I didn't see that earlier. Thank you for that. Okay, so number 19. Let's see if we can figure this out. The supplement of an angle, we'll call it X, plus 42, find the angle. So an angle plus the supplement plus 42 is going to equal 180, right? This is number 19. It says the supplement angle is 42 more than the angle. So we have the angle plus its supplement plus 42 is equal to 180 degrees. Let's solve that. I'll read it for you. The supplement of an angle is 42 degrees more than the angle. So here's the angle. Here's the supplement. They have to equal 180. You all see that? This is the mathematical rendition, for lack of a better word, of problem 19's word problem, right? If it's supplemental, it's going to be equal to 180 degrees. If the supplement plus the angle, the supplement is the angle plus 42. So the angle, its supplement plus 42 is 180. Let's see if we can solve this. Why don't you try and solve this and give me an answer? This is number 19. Okay, you got to do one more thing still, Elisa. You got this, but now you have to do one thing, right? Because it's x plus x is 2x. Okay, good job, Ariana. What do you have to do? One more step, Elisa. You see it? There you go. So an angle plus that angle plus 42, which is its supplement, equal 180 degrees. So x plus x is 2x plus 42 equals 180. Subtract 42 from both sides. I have 2x equals 138. Divide both sides by 2 to get x by itself. So we have 69. If you wanted to figure out its supplement, it'd be just 69 plus 42, right? Which is 138, of course. No, hold on. No, it's not. 9, 10, 11, 6. Yeah, 6, 10, 11. It's 111. Because 111 plus 69 is 180. So these two angles together equal 111 plus 69 and 180. 111 is one angle, 69 is the other angle. X equals 69 is the answer. All right, let's do number 20 together as well. All right, the complement of an angle is half of its angle. Find the angle. So I have an angle plus half of its angle. You could do half, but let's just do 0.5. See if you can figure that out. Complement's 90. Make a mathematical problem for it and solve for that angle. See if you can figure it out. Close, but really they can't. If two angles can't add up to be 90 if one is half its size, because 45 and 45 is 90, Ariana. But that's a good guess. That's what you would think, but that's kind of, again, a little bit counterintuitive. But it couldn't be when you really think about it in the end, because two angles together would be 90. Well, they can't both be 45 if one is half of the other. Anybody else? I appreciate the guess, though, and I appreciate the participation. Sheet ranges. See if that helps. Angle plus half of its complement is equal to 90. You could almost do this in your head, honestly, couldn't you? Because a measurement, what two numbers, one when added to half of its number equals 90? Yeah, there you go. Ariana, good job. It's the lower of those three numbers that you have, but you have both of the numbers of the two angles. Okay. Let's do it algebraically though. Ariana's getting it. She doesn't talk much, but she does math well. We'll call this 1x. 1x plus 0.5x is 1.5x equals 90. Divide by 1.5, divide by 1.5. X equals 1.5 into 90. Move this over one time, move this over one time. Okay. 15 goes into 96 times. 6 times 5 is 30. 6 times 1 is 6 plus 3 is 9. Add 1 0 because that's where your decimal is. There's your answer, 60. X equals 60. X equals 60. 60 plus 30 equals 90. The two angles are this angle added to, and the other angle is half its size. Half of 60 is 30. 60 plus 30 is 90. 90 equals 90. There's your check. After seeing me do it, on the count of 3, thumbs up if you get it. Thumbs down if you're still a little confused. On the count of 3, 1, 2, 3, go. All right. All right. Let's go to 11 and 12. Real quick, we'll do them. Let me draw the diagram. This diagram is actually on the previous page that you don't have. So let me go ahead and draw it. It looks like this. It's got 1, 2, 3, 4, 5, and 6. And it tells us that and it's got UTS. W. STUW. Okay. So it tells us that UT is parallel to WS. So UT is parallel to WS. It wants us to prove that angle 1 is congruent to angle 5. So we have 1 and 5. You can kind of extend this out, right? So look, 1 and 5 are alternate interior angles cut by this transversal. So of all those 5, A, B, C, D, or E, which one of those talks about alternate interior angles proving congruency? A, B, C, D, or E? Letter A. If two parallel lines are cut by a transversal, then their alternate interior angles are congruent. The alternate interior angles are congruent. Okay, let me switch colors to red. For number 12, it says this: UW is parallel to ST. UW parallel to ST. They want us to prove that 4 and 5. 4 and 5. Okay, so these are the two parallel lines here. These are the corresponding angles. 4 corresponds to 5. So I know that 4 is congruent to 5 because UW and TS are parallel. This line, UT, is their transversal. These two angles are corresponding to each other, and corresponding angles are congruent. Letter B. So 11, number 11, the answer is letter A. 12, the answer is letter B. If two parallel lines are cut by a transversal, their corresponding angles are congruent. All right, turn your paper over. And let's do this. When we talk about triangles, we know that if they're congruent to each other, we also know you have to get the order of the letters correct as well. Okay, and if they're equilateral, it doesn't matter so much, but let's say they're not equilateral. So AB corresponds to DE, BC corresponds to EF, and AC corresponds to DE. Now, what happens if you flip this triangle, though? It's still, let me do it. Let me just clear the whole thing. Let me give you something that looks like this. See how I flipped these triangles? We'll call this A, B, C, D, E, F. Okay, so now look. Thumbs up right now if you're participating and watching what I'm doing, because I want to make sure you see this. On the count of 3, go ahead. 1, 2, 3, thumbs up. Okay. All right. So you see how AB is connected to ED because I flipped these around. BC is connected to EF, and AC is connected to DF. So those are connected to each other. And when you do the order of the triangles, you have to keep those in the right order, even if they're flipped around. Okay. So that being said, let's look at number 8. if they tell you the triangles are congruent, you have to make sure you keep the sides the same. So in our illustration, it doesn't even give you the triangles. It just tells you they're congruent. It says triangle JKL is congruent to triangle DFG. Okay. So J connects to D, K connects to F, and L connects to G. Okay. So watch. They don't even show you the triangles. They just know that the first one corresponds to the first one. The second one corresponds to the second one. The third one corresponds to the third one in those orders. Because they told you they're congruent, they're also implying that this angle and this angle match each other. Okay, so that being said, JK connects to DF. So JK is congruent to DF. KL connects to FG. And they're congruent, and they're congruent. Okay. Then JL and DG. Okay. So of all of those letters, the only one that of A, B, C, D, and E on number 8 on your paper, the only one that keeps those consistent is letter A. Thumbs up if you see exactly what I'm talking about. Thumbs down if you do not. On the count of 3. 1, 2, 3, go. All right. No thumbs down. All right. So the answer to number 8 is letter A. Let's go on to number 9. Okay. They have these two triangles here. They look like this. It's told us in the definition that they're congruent. Okay. So by sheer, and again, eventually they're going to tell you you can't assume things. They haven't given us the order of the triangles, but just by visible sake for right now, just to show you corresponding lines, we're going to say that we're going to visibly see which one seems congruent. So this is green. I know it's hard to see the green on the red, at least for me. And this is green. So these two are together. Okay. We get some blue. The longer line is there to that. You see how I've just assumed by sheer size and appearance, the shortest side is congruent to the shortest side. The longest side is congruent to the longest side. And the middle of the 3 sides is congruent to the middle of the 3 sides. You all see that, yes? They're not oriented the same way, they're actually turned, but that's okay. So now let's go ahead and see if we can make some sense of these problems. Okay, I gave you color coordination there because Mr. Soto is trying to be a help to you. So WVU is going to be related to which of those? It's going to have the smallest angle as the interior, right? So you're going to go W. So watch the colors. Blue into yellow, blue into yellow. RPS. Now, you can sometimes invert angles, except here you got to make sure you start with the R because you're saying the exact angle and the exact orientation as well. So you see the blue into the yellow, the blue into the yellow. So the answer to number 9 on the blank, this is the blank, RPS. Okay. So the arrow here means it's corresponding to it. For number 10, they're actually going to use the congruent sign. So they have angle V is congruent to which angle. So you're going to want to do an angle, and all you need is one letter. Okay? Which letter? It's going to be angle V is congruent to angle P. You all see that? Thumbs up if you see it, thumbs down if you don't. All right. I told you this is a little bit easier than the last couple lessons. Now we have VU. Now this one you could actually use two of them because, and you should go in the order, but theoretically you wouldn't be wrong if you reverse the order because it's only two letters. But you should. So you have VU is congruent to which one? So I have VU, you should go this way, PS. Line segment PS. So the answer to number 11 is PS because you see how these are connected to each other. All right. Let's do number 12. An acute triangle blank has an angle that is greater than 90. Always, sometimes, never. Well, if it's acute triangle, none of the angles are 90 or more. So the answer to number 12 is going to be never. An acute triangle never has an angle that is greater than 90 degrees. Number 13, corresponding angles formed by parallel lines are always congruent. Corresponding angles formed by parallel lines are always congruent. Number 13 is always. All right, let's go ahead and do number 14 here below, and that'll give you some of these answers. And then maybe I'll pull up quickly, if I can do that real quick, one of those proofs and just show it to you real quick. Okay, triangle ABD prove that the measurement of A, looks like they're missing something right there. Oh, given just for triangle ABD. That the measurement of A, yeah, it's honestly just going to be the sum of measures, letter B. The sum of the measures of angles of a triangle are 180. So how do we know that it's that 1, 4 and A equal 180? Because they told us it's triangle, letter B. All right, that's almost too easy. They were trying to throw us off there. Okay, let me do this. Let me share my computer screen with you. And then we're going to let me get off of this. Let me go to share. I'm going to show you how to do one proof. Okay. Can you see this here? Okay. I can't write on the whiteboard and I can't write on this because it doesn't let me, but I'll step you through it. Okay. Here's the proof that we're going to do. It says that triangle DFH, let's look at it, DFH and triangle EGI. Now they flipped it, but they got the order in the right order, right? I told you that that's important. So, but honestly, in this one, it doesn't even matter because all angles in a triangle, an equal angular triangle, are 60 degrees. Okay. So this is all you're going to do for this proof. It's a 3-step proof. Okay. The first one, you're going to write your statement, then your blind, and then your reason. Okay. Statement number 1 is your given. So just say angle DFH and angle EGI are equal angular. That's your statement. And your reason is because they told you that, given. Number two, you're going to say angle D and angle EGI are 60 degrees. How do I know this? Because every angle in an equal angular triangle is 60 degrees. Then you're going to say angle D and angle EGI are congruent. If they're both 60 degrees, then they're congruent. So this is how this works. So it's just a three-step proof. The first step is the given. The third step is the proof. The middle step is that these angles have to be 60 degrees because they're angles inside an equal angular triangle. Okay? Let's see if we want to tackle this one. Given angle 1 is an exterior angle of URS. Okay? This is also going to be a three-step. It's going to be very easy. It's going to tell you all you have to do is R is equal to 1 minus 3. Let me make sure that's correct. Let me see. It's a four-step, actually. Oh, hold on, what's in? It's 23. It's a four-step. It's right here. Given, this is a score key I'm showing you right now. This is the exterior angle of a triangle. We just learned that last lesson. Then you subtract it out. Then symmetric property. That's the one we learned. That's the actual proof there for 23. Let's see, 22 was the one we just did. Oh, it's right here. This is 22. Yeah, substitution. Exactly what I showed you before. Given, they're both 60 degrees, substitution. Then we have the given, the exterior angle theorem, subtraction, because you're subtracting it, then symmetric property. So those are those two proofs that you have right there. Yeah. All right, we are out of time. Let me stop my share. All right. It's been real. It's been fun. We're going to work on those proofs a little bit more. We'll probably do one more week of no constructions just to really get us honed in on those proofs and help you out with those along the way, because those seem to be the places that were the place, I should say, that we're having the most difficulty. So all that to say, anybody have any last minute questions? All right. It's been real. It's been fun. It's also been really, really fun. And we will taco with you on Tuesday.